Okay, well, hi everyone. Nice to see you all here. This is the launch of the new Nadara Yaw Misalignment Challenge run on We Do Wind, together with Nadara, obviously. My name's Sarah Barber, if you don't know me. I am from the Eastern Switzerland University of Applied Sciences, and I run this We Do Wind platform. And so the idea of this launch webinar is firstly, I want to introduce you to We Do Wind. I think some of you who have been to previous challenge launches are going to be hearing the same thing, the same thing again, but it changes a little bit every time. So there'll be a brief introduction to We Do Wind, and then after that, I'll pass on to the Nadara colleagues, Katerina and Tanya, who are here. Maybe there's some others here as well. Who will tell you about Nadara, what they're trying to do, and then they'll talk to you about this new challenge, what the goals are. After that, we've got a bit of a description of how to take part in the challenge. So we have some instructions. We want to take you through it briefly. We'll show you the space, we'll show you the data, and then if there are any more questions, we can have a Q&A period in the middle. So does anyone have any questions or anything to add before I start the introduction to We Do Wind? Maybe what I can quickly share while I'm talking is the link to the space. So if you haven't accessed the space yet, you can already start accessing it and looking at it while I'm talking. Yeah, so We Do Wind attempts to address quite a well-known pain point that in wind energy we have all this data, but it's for several reasons it's a lot of it is locked away, and so we spend a lot of time wrangling with data. Companies build their own cleaning and analysis codes and don't necessarily share experiences or share code. There's a lack of common standards to describe the data and the metadata. And also, some valuable experts can be stuck in a kind of low-value tasks. If valuable experts are spending 80% of their time messing around with data, it's not really the best use, might not be the best use of their skills. And then there could be cutting-edge methods which are being developed at somewhere in some university or some company, which people actually don't know about, or there hasn't been like a proper comparison of how well the different methods work. And therefore, some cutting-edge, really good methods might not be being used. And what we've seen is that companies tend to struggle with these same challenges in isolation. And so we think that we need more collaboration. It doesn't mean we think everybody should collaborate with everything and share everything, but we think there could be more. There's some areas where we could have more collaboration. And so the idea of We Do Wind is that we help unlock this value of data and kind of reduce this wasted effort. So we call it an open innovation platform, and it brings people together with solutions and data to try to unlock its value together. It was founded at my university by me and my colleagues, and recently we actually founded a non-profit organization so that we can deal with the organization separately. We've got 500 and more members from research and industry, and if you go to the welcome page, it kind of looks like this. There's a description of the different areas, and it's not just for running challenges. So you're currently in this meeting because we're talking about this Nadara challenge, but it's actually got a lot of other stuff on it. So it's kind of based on this thing we call the We Do Wind blueprint. And the blueprint has these 4 different communities. So we have this collaborative problem-solving community where we're trying to get people to share data. So the idea is that a company like Nadara comes and says they have a particular challenge. We try to get the community to solve it, and they share some new data sets in order to allow this. But apart from that, we have some other communities. So we have an information model community where people are trying to define standards for describing data. And we have a community, an open data and code community, where people are defining like best practices. So we define some recommendations for making data more fair, findable, accessible, interoperable, and reusable. And we also have a community of people using data. So recently we started a group who are developing like an operational data ontology from that group. And we also have a jobs portal, which isn't fully running yet. And we're building a knowledge hub, which also doesn't exist yet. And we publish our ontologies on this techno portal. So it's kind of a more wide-ranging thing than just this challenge community. But today we'll be talking about the challenges. So who is We Do Wind for? First of all, you have asset owners or data owners who have access to data. They may be struggling to apply like the best analytics or access them. They might not know how to publish data openly. They might also lack information about the quality of different methods. And then you have researchers, data scientists, or students who, I mean, you're developing all these different analytics, but people really struggle to access real data for training or for validation. You spend too much time wrangling data. You might also be looking for jobs or project partners. You might also want to co-create information models and standards. And then we have recruiters. So recruiters are trying to attract talents with digital skills. They might be struggling to access the right people. I think we've heard it quite a lot that people who are, really good at data science, they might not come to the wind energy industry. They might go work for Google or whatever, and then we kind of lose these talents. So one of the ideas of We Do Wind is also that we get people solving challenges, and then we get them into the wind industry. So what asset owners can do on We Do Wind is run a challenge like we're going to talk about today, publish the data as well with our help on their own terms, and then but they can also participate in working groups where we develop ontologies or data standards and recommendations. So generally the benefits for asset owners is that you only share what you want to share, so you have full control. You save money because you get access to innovative algorithms and insights. You become more innovative, you gain visibility, you possibly get access to talent, people who are solving the challenges. You get to work with standardization, so you reduce redundant efforts, and also you can show a positive ESG performance. And then researchers, data scientists, and students, what you can do is you can participate in a challenge, which I guess why lots of people are here today, because you're interested in participating. As well as participating in challenges, you can also access, we don't have a knowledge hub yet, but we do have a list of open data sets, which is quite useful. You also get to showcase your work and collaborate with others. You can also contribute to some of these other working groups listed here, which you can see on the platform. I won't talk about it now. And you can also meet like-minded students. So we have a student space where we have regular talks and meetings. We have even a community lab where you can volunteer to help further develop We Do Wind, and then a job portal as well. So yeah, the benefits for researchers, data scientists, and students is really you get access to real data. You can apply your methods into real challenges. You can collaborate with people, showcase your work, get some career visibility, become more innovative by experimenting with new methods. You get to learn through practice, and ultimately you get to contribute to the energy transition. And then for recruiters, if you advertise open positions on the job portal, then the people who are participating in these challenges will see them. You can also sponsor We Do Wind to raise the profile of the company, or you can run We Do Wind challenges from the point of view of recruiting as well, and get direct access to people. So there's a summary of the benefits for recruiters, basically access to special talent, insights which go further than just the CVs, and early access, reduced hiring risk, etc. So just a couple of examples. The first challenge we ran was actually with EDP, where we actually quantified the savings. So we ran the challenge about fault detection. We actually applied a cost model and showed that the new methods could save this amount of money per turbine per year. We also did a challenge, some of you might have participated in the Hill of Towie challenge with RES, where we had hundreds of submissions. We had and we also have another challenge with the company RTDT, who do pressure measurements. We actually currently have a challenge about corrupted measurements, in case anyone's interested in that topic. And also together with Nuveen Infrastructure, we ran several challenges, we still are, where they also got a load of new codes delivered to them. So the team, who is this non-profit organization? So I'm basically the president of this organization, We Do Wind. As I said, I'm at the Eastern Switzerland University of Applied Sciences, which is OST for short. I also lecture in fluid dynamics, and I also lead this IEA Wind Task 43 that some of you may have heard about as well. And I chair the Diversity, Equity and Inclusion Committee of the European Academy of Wind Energy. We have a board of directors, which is these people here on this list are part of. So we have some people from academia and industry. We also have an advisory board of people from academia and industry who are listed here. We're also supported by my team. So this is just a picture of the people who work in my team, who kind of support the whole thing. Yuri is the main person who works on this, who's going to talk to you later today. And yeah, so one of the other things that people ask about quite a lot is kind of the impact and the sustainable development goals. So if you participate in We Do Wind, you can kind of show that you that you contribute to the Sustainable Development Goal 7, 13, 4, because it's about education as well and getting access to information, learning. 9 is about innovation. 17 is about collaboration and partnerships, and then even responsible consumption and production, because we're sharing what we're doing. So that's a conclusion about We Do Wind. Does anyone want to ask me anything now about the general idea of We Do Wind before we get on to the Nadara part? I see Alex is here, actually. Luckily, I didn't say anything bad about you, Alex. Okay, so I'll pass over then, I think, to Katerina. Do you want to share your screen, or do you want me to just click when you tell me to?
Yeah, you can just click. I'll present from here. Yeah. Thank you, Sarah. Thank you so much. Okay, perfect. Thank you so much for this introduction. I'm very happy to introduce you to Nadara now. You can just click. Basically, Nadara is a renewable energy producer, but we don't just produce it. We work closely with the environment and the communities that we integrate to create a real positive impact wherever we operate. That's what drives us, together with nature. On the next slide, I can just tell you that we are an independent power producer operating across Europe and the US and generating over 9,000 gigawatt hours of energy in 2024 alone. We have over 800 employees, over 4 gigawatts of installed capacity, and our portfolio is composed of more than 200 sites across Europe and the US, and includes wind, solar, biomass, and energy storage. You can go ahead. Basically, we are managing a diverse and growing energy ecosystem. This means managing a larger number of assets across different geographies and different conditions, and that comes with a lot of data. And the real challenge here is not just having the data, but extracting the most value from it. You can click, please. Basically, for this challenge, we joined forces from 2 different departments. Tanya, who is here in the call, from asset performance, and bringing us the challenge of Yaw Misalignment and the challenge that we'll present to you today. And also the team from innovation with Andre, representing the AI and data, and also with the help from our team, Kaya and Oliver, also here today. Our main goal is to continuously improve our assets performance, so this will be very helpful to have these two teams together to present you the challenge. Okay, go ahead, please. Perfect. So regarding Yaw Misalignment, today we are launching the Nadara Yaw Misalignment Challenge. The main goal is to detect hidden performance losses using high-frequency data, because yaw misalignment has a huge impact at scale. Even a slow yaw misalignment can lead to significant losses at a Nadara scale. Traditionally, we rely on 10-minute SCADA data, but at that resolution, we can lose a lot of important dynamics due to the averages. So things like turbine response, wind variability, and short-term effects are simply lost. That's why in this challenge, we are using high-frequency data at 15 seconds resolution, which capture much more detail, and this is how we can see how turbines is really behaving. So with this challenge, we want to go one step further. The main question is, can we use high frequency data to help us uncover what traditional approaches miss? We are not just looking to detect yaw misalignment, we are also interested in estimating it in a reliable and scalable way. So the challenge is officially live today. We'll have a few checkpoint interim webinars along the way to see the progress and to help you with some doubts that you might have, or all the other way around. And finally, we'll have a final webinar in October where we'll look at the results. We have a complex problem with important data that Nadara already has. So we are really excited to open it to the community and to have your help solving it. Now, we would just like to get to know you a little bit better. We'll ask you some questions. And so can you please scan this QR code, please?
I'll
just share.
You might have to share your screen now, mightn't you, to do that? Yeah.
I'll do that. Okay. Sorry. Okay. Are you already seeing it my screen correctly?
Yep.
Okay, perfect. So just this is just a quick getting to know what you are feeling about this challenge. What's the first word that comes to mind when you heard about this challenge and about this presentation?
It's a nice question.
Yeah, I can just, let's see, yeah. Okay, fun, data.
Disguised employment, I like that.
So data, I think it's the biggest word that comes to mind to all of us. Collaboration as well. It's really fun to join both worlds, and important as well. Okay, feel free to add your word now. We have just a few seconds before we move to the next. Yeah, opportunity as well. Okay, let's move forward. Now we want to know, what is your academic background? This is interesting for us to know, just get a quick sense of what is the background of the participants of the challenge, of this Nadara challenge. Already having some answers. Let's look at them. Okay, a lot of engineers. I'll give you some time to answer it. I think this is really insightful that we have different backgrounds, academic backgrounds, to help us get to a strong solution that is reliable. So that's
interesting that no one has written data science yet. Where are the data scientists?
Maybe it's not their academic background, but their experience. Let's see.
Maybe, yeah.
That's the next question I'm going to ask. So have you all answered? Can I move to the next one? Okay, let's do it. So now this is a next question because we want to know the areas of expertise or work experience. It can be like research experience that you have, that it's interesting to the challenge, or just for us to know. So it could be, as you understand, this is a challenge of data, so we want to have data as well. It's interesting for us. We won't do anything with this information, just fun to know. Okay. So data here, AI. Exactly. Perfect. Okay, I think we have some answers now. So let's move to another part of this Mentimeter. Now we will move to a quick guess. So basically, you'll have a question and you have to guess it quickly. So how many wind turbines does Nadara have? Do you think Nadara has? I'll just show the answers after most of you answered, so it's fun this way. This information was not disclosed on the slide, so this is just really to guess and see if you have a sense of our assets. Okay. Anybody else wants to answer? Are you ready? Okay, we're still having some answers. Okay, let's do it. Oh, interesting. So we have a lot of different answers, which is very cool. But the most common one was actually the correct answer. So we have 2,000 turbines, more or less. So this is interesting to see what you think. And now let's go to a different question. Also, oh, no, yeah, exactly. This is like a game because it has like a correct answer. So let's do it. The quicker you answer, the better. What problem is Nadara trying to solve with this challenge? Now you have 4 different options. So are we trying to solve this because we have high maintenance costs, or because we have hidden energy losses from turbine misalignment, grid instability, or oh, nice. So perfect. You all answered correctly. This is great. You're very concentrated during the presentation, which is very good. I'm very happy with the result. And now, finally, we want to know what you are most interested in participating in this challenge. So do you want to get your work recognized, win a prize? You want to share your ideas, meet new people? So all of these are very interesting ideas to participate in this challenge. We just want to know which one resonates with you. When we reach 17, it's my number here. Let's show it. Okay, accessing real data is the chosen one for 6 of you, so the majority, and also very interesting results here. Okay, that's it from my side. Thank you so much for letting me present to you, Nadar, and the challenge. And now I'll move it back to Sarah for the rest of the presentation.
All right, thank you. By the way, it's really interesting to see how people answer that last question, different challenges. We actually have on We Do Wind, we've actually we've got a space where we actually compare the answers. Anyway, I'll get to that later. Yeah, so the next part of the presentation is just to show you the We Do Wind space and like the whole point of doing it on We Do Wind. And at some point I'll pass on to Yuri. If you can prepare yourself psychologically, Yuri, to take over. So if you go to the Nadara space, you'll see this. And if you click on things, you can see you open like posts. So for example, here, it's just really explaining to you what this space is about. And the main content is if you click on this challenge here, and then we have a description of the challenge. So we've basically got a background and motivation, what the point of the challenge is, why it's important, and then we have the goal. So the goal is to develop and compare methods for identifying yaw misalignment driven underperformance using high frequency SCADA data. And what we're asking you to do is look at the provided data and then submit a list of turbines and time periods for which you identify yaw misalignment together with the actual value of the predicted value of the alignment. And it should focus on detecting the power underperformance. I realize we've repeated ourselves there. Maybe I can delete that last sentence. But so the evaluation will be done in two ways. And so we're going to have two leaderboards. So the overall evaluation is the economic value at fleet scale. So the score reflects how much energy a large fleet could recover if the method would be deployed over all turbines. So it's accounting for the accuracy of the predicted offset and practical aspects, which includes like the cost and time leads for making additional measurements. So if you didn't have the predictor, you would have to go out and install a measurement system. And so methods that generalize to unseen turbines and offset magnitudes without requiring per turbine field measurements are rewarded most highly, because that means they've got a higher potential for fleet-wide impact. And so you can develop solutions along one of these three tracks. So no labeled data or unsupervised, a small number of reference turbine measurements, or fresh measurement for every turbine, which would be supervised. We'll come to that in a second when we tell you about the data. We're actually going to have two leaderboards. So the first one's just going to be the pure model performance. And the second one is going to include economic aspects of the type. And that will then decide the winning submission. But we want to provide the first leaderboard as well, so you can see the difference between the two. I think, Yuri, you can maybe provide an overview of the data set now, if you don't mind.
Yes, sure. Can everyone hear me?
Yep.
Okay, so the dataset is currently uploaded on the switch drive and is available as a data connector to a collaborative data science platform called Renku. I guess we'll talk a little bit more about Renku in a moment.
Yeah.
But right now it's just a folder on a switch drive. The link is provided. It's password protected just for the participants. You will get the password after you have registered for the challenge. And the reason we decided to go this way is if we find some like errors or some inconsistencies during the challenge, I mean, these things can be tricky when working with data. We would want to correct it right away. But we expect that by the end of a challenge, after we are done and the data sets are all have been proven that they're nice and good, we will also publish them on Zenodo for archival purposes and data science reproducibility purposes. So thank you again for Nadara for releasing them under the CC BY license. So the data set themselves, you will find 3 different files. They are Parquet compressed files. The first file will have and the biggest one is the unsupervised learning set. So it has 4 wind turbines and it doesn't have any labels to it. We don't have any ground truths available for this data. So you can use it for your unsupervised learning, for pre-training, if you want to try to do transfer learning, but we don't have any ground truths for that data set. Then the second one is the labeled training data set. So if you went the unsupervised learning route, you can use it yourself for verification and validation. Or again, if you want a transfer learning, few-shot learning routes, you can use some of the data, use as much as you want. The idea here being, as Sarah has mentioned before, is that the leaderboard will be scored on practical impacts and practical possibility of implementing the method. So generally, we will release more details a bit later, but generally the methods that require less measurements would be more favored in terms of implementation, because it would be just more possible to deploy them rapidly. And the throughput seems to be like one of the main challenges, and like practical challenges in this case. Then if you do not manage to go the unsupervised learning routes and you try to go through the supervised learnings, you can, there is also a data set that contains only the data, but some of the labels removed. So we will be using that one for validation and for to create the leaderboard. We also have withheld a certain amount of label data that will be used for a test data set. So by the end of the competition, we will check the method against the test data set, the one that has not been seen by any model. And it has also some of the data that would be outside the range that you will see in the data. So we will check how well does the method generalize to a different wind turbine, and also to possible extrapolations outside of the single wind turbine in terms of the offset. In addition to the files with the data itself, we also provide something called ML croissant specification metadata. You can read a little bit on it on the specification website. It's a metadata specification developed by Google specifically for data science challenges, and it basically provides all the contextual information and describes the fields in the data, what are the units used, all the conventions. If you have any questions on that one, feel free to drop us a message, and because I mean, there are always some imperfections, as these things are always challenging to prepare. And for people unfamiliar on how to use this these kind of data formats and metadata formats, there is also a Jupyter notebook, which shows some examples of how to load the data, how to access metadata, how to read it. And so all of that is provided there. Some additional notes. We do have timestamps along with the data. Obviously, the yaw offset is a slowly changing value. So if we ask participants not to use the absolute timestamps as their feature, because when they go for the supervised learning, so we ask to use. So what we did, we basically split the label data into 30-minute sessions, and we ask you to use the relative time within the session if you want to use any chronological time sequence type of methods, the one that have some memory on the previous features, also have some kind of time-dependent information. We are not hyper fixed on this 30 minutes. If someone, however, can demonstrate that the bigger time window could be useful, like 1 hour, we can consider reframing the sessions into the 1 hour chunks. Obviously, there is a limit to that. Ideally, it would be let's say the label of the sample would be 1 day of a measurement, but the practical constraints are that these measurements are difficult to have. And also in the practical application, it will be difficult to obtain many of them. So we don't have that many daily measurements to have enough of samples for the fully trained approaches, so fully supervised approaches. So this is about the data set. Any questions so far?
Maybe we'll save questions to the end because the questions might be related to the rest of what we're going to say, and let's just do all technical questions at the end, if that's okay. Does it kind of make sense?
Okay.
So I'll just carry on. So that's the data set, and then so if you want to participate, the first thing you have to do is that you have to enter your, I mean, lots of people have done it already. We have like a registration form, and the reason we have that is because there's lots of people who join this space just to look at it. Actually, that's the wrong link. Oh, good thing I noticed that. I'll correct that. There's this sub document here, which is called challenge registration, which some people must have found their way to, because there's quite a few people entered it already. And so what you can do is that you might be able to access that file directly, but if you can't, then just click on that, and it's just a Google Doc, and you can enter your name in. The point is there that you need this participant ID for the leaderboards later, and also if we know who's taking part, we don't have to message everybody in the entire space all the time. And so what you can do here is that you can put the team leader name, organization, and then team member names. That's helpful for us because if we're contacting people and we know that they belong to one of the teams rather than they've forgotten to put their name down in this registration form. We'll talk about Renku in a second, but you can put down here if you're intending to use Renku or not. And if you are using Renku, we need your GitHub usernames and the email address associated with that. And then if you're looking for somebody to work with, you can put yes, and then you can work together. So at the moment, only one person has put yes, which is a bit unfortunate. That's just me with an example. But as soon as now 2 people have put it, thank you, Luca. So for example, if you see here, Luca has just put his name down. He sees that Ritesh is looking for someone, then you can contact each other. and join forces if you want. It's also completely non-binding. If you put your name in here and then don't have time, it doesn't matter. The only thing that's going to happen is that we might contact you and ask you where you're at. So that's the first step. What I'm going to do is actually right at this second quickly update this link because it's a bit unfortunate that that was the wrong link. Let me get to the participation instructions. So let me just put the oops. Let me just put that link in here. And then the second step is to start working on it, which is kind of obvious. You've got two choices, right? So you can just download that data and do whatever you want with it inside your own environments, or you can use Renku, which we just prefer partly because we're kind of testing how well this works, but we don't want to make you do anything. So yeah, we would be really grateful if some people could actually use it and test it and see if it's actually valuable for you. And Renku is maybe let me just show you the homepage of Renku. Renku is a Swiss project which is run by the Swiss Data Science Center. I actually can't get to the homepage when I'm logged in, but it's a data science platform that allows you to basically connect code, data, and run time. So it's got a running environment, and which we've set up already. So you can. It's really nice. I mean, maybe Yuri, I guess you've got it open at the moment. You can show in a second what it looks like, and you can basically just start working on it immediately instead of having. It depends how you work, right? If you're used to working with data science and you've got your own environment set up, then just do it yourself however you want. But if not, you can use this kind of ready, prepared environment, and it's actually really nice because you don't have to check all the connections, and it should just work immediately. So we'll tell you about that in a second. But step 3 is to then submit results. So this is kind of an open innovation thing, but it's also a competition. So you can decide yourself, like if you don't want to share anything with anyone, you can submit the results right at the end. But if you quite like the idea of discussing what you've done and learning, I think Alex from Res is here, and he ran this previous challenge about the Hill of Towie, and he said one of the really nice things about having these interim webinars was actually like this exchange. So we looked at the leaderboard and people presented what they'd done, and then people exchanged ideas, and then actually had ideas for improving it by like learning from each other. And so we don't want to force you to do that, but if you're kind of interested in learning from others, then we're offering that, which basically means that you can submit results at any time, basically. And before the interim meetings, we'll do a call and ask you to submit like a description or a presentation if you want to present at that meeting. But whatever, at some point, at the latest, at the deadline, you have to submit the final results, and we've got a separate instruction for doing that in part 7. So part 6 is about using Renku. I'm just a bit worried about time. We've got 13 minutes left. Yuri, I don't know whether you can just like do a really quick without going through every step, because people can read that themselves. Can you just show them the environment, and people can read the steps themselves about what they have to do. But you basically just have to set up an account and then copy the template. Yuri, do you want to show what it looks like?
Yeah. So you basically when you click the link, you get this to this project page. This is a template. So I already created a copy, but what will be different for you is here on top it will say make a copy, and what it will basically do is create your own copy. It already has all the data folders and everything attached to it. And then all you have to do is click launch, and it's going to launch the compute environment. Just follow the instructions. We did get a large compute environment with 4 CPUs, 16 gigabytes of RAM, and 10 gigabytes of hard drive space. And I already have it launched here, so we don't have to wait. What you will be greeted is basically this environment where you can either start your own notebook, but also it includes already the OpenOA code for you we precompiled, but you can refer to OpenOA documentations, which can do some that already has some yaw misalignment things. You can already start testing those. And as I said, it already includes all the data. So if you go to the data itself, I mentioned before, there is a notebook that tells you a little bit how to read the data. And because this is already a precompiled computational environment, only thing you have to do is select the static yaw misalignment Python environment, and then it has all the libraries, all the dependencies, everything installed, and you just basically have to click, and it's gonna, for example, like load the data using pandas, or explore the metadata using the ML croissant package I mentioned before. Some nice things about it. I just needed it to load. It's a bit slow. But
by the way, I just noticed that that step that you did where you selected that environment, I don't think that step's in the instructions on the platform.
I will
should
have
add
to
that.
add it. Yes.
But all the other steps that you said are all in there.
Yes. So we can also access metadata. We can get information about all the fields, and let me show this. It's actually one of the things we're quite proud here. It uses linked data, so we also link to things like ontology of units of measure. So if you want to full context aware things, it takes some time to load. But anyway, this is the main things I wanted to show. Oh yeah, I was saying you can explore metadata. So each column in the data is not just like a name, but it also has a description, a data type, what units are being used. So for example, a meter per second as defined in the ontology of units of measure, so things like that.
Yuri, we had a question in the chat about the definition of yaw misalignment. That definition is that actually in here? Because yaw misalignment must be one of the fields in the metadata.
Yes. I'm not exactly sure what the question was asking. It is the as far as I understand, the difference between the nacelle direction and the wind direction measured by the LiDAR. The only maybe thing that has to be said that this is a daily label. So even though we have it split into 30-minute sessions, the yaw misalignment, the actual measured one, was happening on a daily basis. I don't know if Katerina maybe add a bit more.
Yeah, it's exactly what you said. It's what we agreed, 30 minutes.
Maybe just so that we actually have a couple of minutes for questions, I'll just take over the screen again, Yuri, and just so feel free to just follow these Renku instructions if you quite like the idea of using it. I think one point is that you have to you have to make sure you save your code in your folder. So here is it, right? There's these subfolders which are already there, and you have to, if you're participant number 5, you have to save your code in the folder for participant number 5, right? Is that still like that?
I'm not sure I made the participant number 5 folder yet, like the subfolders, but yeah, that is how it's gonna be. 2 things to note, and I wrote it there. The submission folder is only read and write. You cannot delete or edit the data. So if you mistakenly put something there and you want to delete it, you have to message us because we have the permissions to delete from that folder. And the public workspace folder is open for everyone. So what I would highly recommend is to add your own data connector. So it's quite straightforward. You will see from a user interface. You can add your own Google Drive, Switch Drive, Amazon buckets, whatever you wish as a data connector, and it will be your private space where you can keep the data.
Yeah, so you can either save your code in a subfolder according to your name, or you can add your own private data connector if you don't want anyone to access it. And then if you have a version that you're happy to share, then you can put it in your folder. And we've got a folder called submissions where you can submit your results. We haven't actually given you the instructions for submitting the results yet, and we haven't got the dashboard or leaderboard set up yet, just because we haven't done it yet, and also because you're probably not going to submit results in the first week. So actually we'll give you an update once that is live, and then we assume you're going to spend a bit of time just playing with the data at the beginning. So yeah, we'll tell you when all that's more available. Does anyone have any questions? I presume that people have got more questions. Feel free to put your hand up or just speak or write in the chat.
Hey, I had one question, I guess, on the labeled turbine. Was that a turbine that had a kind of known defect before, or was it when where simulated defects were added, or was it just a normal healthy turbine?
I guess Katerina, that's your question for you.
Sorry,
Yeah.
maybe it could be for me, but I got distracted with all these comments in the chat. Can you please repeat it?
So just a question around the one labeled turbine, whether that was a turbine that had a kind of known yaw misalignment issue beforehand, or whether it's something else simulated, or whether it was actually just a normal healthy turbine with any small misalignments.
We have both cases. So I'm not. Sorry, I don't recall by heart the number of wind turbines available in the challenge. We have healthy wind turbines and wind turbines with misalignment at a certain point and corrected, and turbines with a misalignment that was not corrected.
So the labeled one is you will see in the labeled data you will see like a quite big offset. So that was what I would assume would be pre-correction, and then you will notice that after some time the yaw misalignment becomes much more centered around zero, much closer to zero. So that would be post-correction.
Thanks, Yuri.
Excellent. Yeah, thanks for clarifying.
Any other questions?
I'm pretty sure questions will arise in the next webinar. It will be a ton of them.
Yeah.
Sarah, may I take these last minutes just to thank everyone for joining the challenge. This is a quite challenging topic for us. We have been trying to understand how to address this based on SCADA data for a couple of years now, and I really appreciate your attempt to support us on this, and I wish the best luck for everyone participating in the challenge.
Thank you, and much appreciated as well. I hope this is going to be a good thing. I just put a summary of the next steps here as well. So I put the link to the challenge description where you can register yourself. You can sign up for the next webinar. So we won't be sending invites around. So what you have to do is go to the platform where the events are here, and then you can download the invitation and then just come. If you have anything you want to discuss during the challenge or any questions, please do it on the platform. Like the idea, one of the ideas of this platform is to document everything that's going on. Like quite often, if you have a benchmarking or a challenge or some sort of collaboration, the information gets spread out everywhere. Someone sends someone an email, and then not everyone's on CC, and it kind of gets distributed. We're trying to keep everything in the same place. So if you want to ask any questions about the challenge, then go to the challenge description, and there's a place for comments here. I say that with confidence, and then I don't see the comments. Actually, that's a really good point here. Sorry, I'm saying it, I'm talking rubbish. You go to the feed. I'm just writing the feed, and you can click on notify, and then we will all see the message. If you want to make sure that I get it, tag me. If you want to make sure that Katerina gets it, tag her, just to be sure. You can also you can contact people individually here over the chat if you want, but I would like to encourage to do everything openly on this feed unless it's a private question. Yeah, so that's basically the thing that I wanted to say. Yes, Alex, your question about the passwords. So the registration procedure is manual. I look on this form here, and I will, like in the next day or two, I will now send you all these people on this list. I will send the password via a private chat on the platform, and I will occasionally check that new people have added. But if you really want to be sure that I send you it, if you're not on this list by tomorrow, if you add yourself, the best thing to do is send me a message on We Do Wind and say, I've added myself, please send me the password, and then I'll send it you. All right. Then everyone knows what they're doing. Hope to see you all at the interim webinar, and yeah, we'll be monitoring the page and keeping updated on your questions as soon as you have any. So yeah, thanks again to everyone at Nadara for the collaboration. And by the way, if anyone wants to come to see us at Wind Europe, the Nadara people and the We Do Wind people will all be there. So come and drop by our stands to say hi. And yeah, talk to you all soon.
Thank you.
Thank you.
Thank you so much.
Perfect.
Thank you all
Thank
for
you, everyone.
participating.
Bye.
Bye-bye.
Have a nice day. Bye-bye.
Thanks, mate.
Thank you. Bye.